Okay, so we've been talking for the past 2.5 weeks about systems of equations. If you had to tell me what a system, so this number 1 here is a system of equations, what does that mean? What is a system?
It's like a unit that holds together, like multiple stuff.
Yeah, it's like there's multiple equations going on, right? But do they have anything in common?
Yeah.
What? They both have a y and they both have an x, so they have the same variables. So could something like this be a system? Why not? They don't have any of the same variables. So the reason that we can solve things like this is because we can use the equations together to solve for missing variables. So for example, in something like this, we have x plus 5 equals 10. These are pretty basic algebraic equations that you guys have started learning. Since when's the first time you remember doing something like that? Maybe first grade. A lot of times in first grade, they would make it look like this. They would just put like a box there and be like, what is that number? Which is, yeah, exactly. That's algebra, right? That's algebra. Okay, thank you, Alfonso. It is 5. Okay. So that is algebra, but we just started in probably 5th or 6th grade, you started putting in variables for it. And now we've started putting in multiple variables. So when you go to solve this one, like Alfonso just told us it's 5, you subtract 5 from both sides, and you get x equals 5, and I say, all right, you're done. You've solved it. How come you can't solve this one? If I just gave you this equation by itself, why can't you solve it? Victoria? You don't have a y, right? You don't know what y is, you don't know what x is, and if you've got multiple variables, you can't solve them. However, when you have 2 equations together, you can use them to help solve each other. Because think about it like this. Think about if I went, let's say that Mr. Adragna was looking for somebody, and he told one of his students, okay, go into Miss Burns' room and get the girl. All right? What if somebody came in, would they get the person Mr. Adragna was looking for? Maybe, but probably not, right? What if he said, go in there and get the girl with glasses? Would they? Okay, they're more likely now. What if he said, go in there and get the girl in glasses wearing a navy hoodie? Okay, now, well, he's not really coming to get you, but okay. So now you know that if they came in, they could get Alyssa. How come? How come they could get the right person? She doesn't have glasses. She's not wearing them right now. So for these purposes, Mike, I want you to say that again. I gave you not 1 piece of information, but 3, right? So you had, her sweatshirt's gray. Okay. All right, so we had girl, we had sweatshirt, and we had glasses. So we knew that Alyssa was the only one. So in a system of equations, you've been given more than 1 piece of information. So you have enough information then to figure out what x and y are. In this case, when you solved it, you ended up getting all reals, so anything could work. Okay? What we're going to talk about today, so we're shifting gears a little bit where we're still working ultimately with systems, but we're not going to talk about systems of equations now. We're going to talk about systems of inequalities. So before we start that, I want to talk to you guys to see if you remember what an inequality is. What is an inequality? Where it's not equal. Yorath? It has less than or greater than, right? So if I said something to you like, x is less than 6, you would tell me that, Gabe, what's one thing x could be? 5. Corolla, what's another thing? 4. Adela, what's another thing x could be? 1. Fatima, give me one more. 2. Okay, all of those things could be x. So if I said to you, give me a list of all the things x could be, how long would it take you to make that list? Forever, like the rest of your life. Yeah, so does anybody remember how we illustrated all the stuff x could be then? Micah? Put the, like this? All right, and then what? It's open to the left. Good. And that means that that picture right there is a number line, and it tells me x could be anything on the shaded part of that number line, right? So anything over there. Now, what we're talking about today is if you had something like this. Y equals y, instead of saying y is equal to, it says y is less than x minus 1. So I'm looking at an inequality, only instead of having one variable, it has how many variables? 2. Okay, that doesn't mean we can't do it. So let's take a look at this. This first question says, how can we determine if 7, 3 is a solution to this inequality? So how would you do that, do you think? Brian?
You plug in 7 with X and 3 with Y.
Okay, how come this one's the X and this one's the Y? That's an ordered pair, right? So we plug it in. What would my new equation look like? My new inequality, sorry.
3 is less than 7 minus 1.
All right, what's 7 minus 1?
6.
Okay, is that true? Yes. So is this a solution? Yes. Good. That's it. Okay, so okay, so that's the first thing we're doing, which is as simple as that. So just plugging in and seeing if that works as a solution. So yes, that works as a solution. Now, if it does not work, what do you put? Yeah, you say it doesn't work or it's not a solution, something like that, all right? Something like that. Now, what if I said to you, instead of saying, is this a solution, what if I said, name all the ordered pairs that work? David, do you want to do that? No, why not? It's too much, right? There's probably... There are actually infinite. There's infinite solutions that would work. So if I asked you to say, give me all the ordered pairs that you could plug in that would work for this, you would take forever to do that. You would never be able to leave if you had to make that list. So is there some way that we can do a line for this, just like we did on a number line here, except the difference is that this only has an X, so we could use a number line. What do you think we'd have to do if it has an X and a Y? On a coordinate plane. So instead of doing it on a number line, we've got to do a coordinate plane because it has an X and a Y. So let's take a look at how to do that. We're going to skip this one, okay? So take a look at this. This is the graph of a coordinate plane, and ultimately we're going to talk about why this is how you graph inequalities. So let's take a look at this inequality right here, which says y is less than 3x plus 4. What do you notice about the format this is in? It's in the y equals mx plus b, except instead of an equals, we have a less than sign, so an inequality, all right? Don't let that affect you. All we're looking at is it in the right format? And it is, which means we can do what with it? We can graph it. What is the 4? The y-intercept. What's the 3? Slope. And both of them are positive, so that means my line's going to go up and over. Good. Okay, so where do I start?
4.
Okay, that's going off the graph. Could I do it a different way? Good. I'm going to go one more. Good. Okay. I'm going to do one more just because I can fit it. Okay, so here's my line. Now, because it is y is less than, I know that y is not just the stuff on the line. It's either it's either bigger than all that or smaller than all that. So when you take a look at this graph, what this is this colored section represents all the ordered pairs that would work for that graph. So for instance, this purple one right here means that if you went to 2, -3, this point is in the colored section, so it would work for the inequality. So this colored stuff is just like this shaded section on the number line. Okay? We're shading a bigger section because it's x values and y values. So I have to take a look at the one I just did, and I'm saying y is less than all of that. So now I've got to figure out where I'm going to shade.
To the right side.
You think to the right?
Yes.
All right, why would it be to the right?
Because it's positive. It's on the positive side.
Okay, but it's telling me y should be less than all that. So maybe to the left?
I think to the right.
Okay, I can see it to the right because it kind of looks like it's underneath it, or to the left because it kind of looks like it's above it. So let's see if we can figure out a different way that we could test this. So for example, let's say I'm just going to shade one and we can undo it if we're wrong. Let's go with what Alfonso said to begin with. Alfonso said, let's shade to the right. Can anybody pick any ordered pair that would be in this blue section? Geraldine. 1, 1 would be in this section. So if 1, 1 is in this section, that means, think back to the questions you just asked, is 1, 1 a solution? How would you test that? Micah?
You put 1 where the y is.
Yeah.
And multiply 1.
Good, perfect. So plug them both in, right? So 1 less than 3x plus 4, and I'm going to put 1 for both. I like what Geraldine did because by picking ones like this, it makes it very easy. Don't pick like 3.5 and 6, like negative 6.2. Make it easy on yourself, right? So pick 1, 1. All right, what's 3 times 1?
3.
Plus 4. What's 3 plus 4? 1 less than 7. Is that true? Yes? Then that means you shaded the right spot. So Alfonso was right. Shade to the right. Okay? Gabe, go ahead. Why are we shading? Go back here. Why did we shade here? Say that louder. X is everything below the 6, right? Over here, y is everything below that line. So y is not just this one order pair Geraldine picked. It's everything that's colored in with blue. Does that make sense? So it's like you're shading in, just like we shaded in the number line. X was everything there. Y is everything here. You're F.
Will it always be to the right side?
No. So that's why I want you guys to get used to doing this like test, because people want to say like, oh, if it's less than, it's always to the right. If it's greater than, it's always to the left. That's not true because sometimes the slope of your line changes, and then there's not really such thing as left or right or over or under. So I don't want you to get it too tied to like, do I go left? Do I go right? Just pick a point, plug it in. If it works, shade that side. If it doesn't, shade the other side. Alfonso.
Please pardon the interruption. Please release varsity boys.
So this photo right here was for a system of inequalities, which we'll talk about tomorrow, where you'd have 2 parts shaded. Okay? So today we're just going to have 1 shaded. Now the last thing I want you to do is, I don't want to just leave it like this. I don't want to just leave it as points. I want to make it a line. However, because it's just less than, it's going to be a dashed line. So when would it be a solid line, do you think, if you had to guess? Gabe? I feel like you were going to say the right thing.
Maybe if like there's a dot on like each line or something.
Not quite a dot on each line. You're at?
Whenever there's the inequality is like greater than or equal to.
Okay, remember how you can have it like this too? If there's a line underneath it, then it's a solid line. Okay? Yeah. Let's go with it. What's the worst thing that you're wrong, right? Who cares? Micah?
Does that like mean something? Or is that
Yes. This means it could be equal to that. So it's shaded on the line as well. This means it has to be this side of the line. It's like having, remember how we did the open circle or the closed circle? This is like having an open circle. Solid line would be like having a closed circle. Okay? All right, so I want you to try.
Do we do the try it?
Why? Because you already did it?
No, because I want to like get a little bit more practice.
I want you to try them just at your boards. Yes, try all 3, but if you only get 2 done, that's fine. Let's do one more example problem. I don't think, did anybody get to number 3? No. Okay, so let's do number 3. All right, so let's take a look at number 3. So number 3 is already in y equals mx plus b. All right, so if it's already in y equals mx plus b, we're already ready to graph it. What if it weren't?
Then we solve it to where
Solve it for y, exactly. So get it to y equals mx plus b. All right, so what's my y-intercept here? Negative 5. Good. So I start down here at negative 5. What's my slope? Negative 1 over 1. Good. So that means I'm going to go down 1, right 1. Good. If that's really small, what else could I do? Good. And I could keep going. And I might as well until I'm all the way off. All right. Is it going to be a dotted line or a solid line? Dotted line, so I'm gonna leave it right like that because I don't need to put any more dots in. Okay, so now I just have to decide if I go to the right or to the left. So I talked about this with a bunch of you. Pick a point, plug it in, and I usually just pick 0, 0, I always pick 0, 0, because then it makes it easier. All right, so if I plug that in, 0 greater than, all right, is there such thing as negative 0? Okay, so what's 0 minus 5? Negative 5. Is this true or false? 0 is greater than negative 5. That is correct. 0 is greater than negative 5, which means I want to shade so that this blue dot is covered, which means I'm going to shade where? Above or below? Above. Okay. Again, guys, there's no easy way to say, like, is it always up? Is it always below? Is it always left? Is it always right? So you've got to just plug in a point. I always pick 0, 0 because it typically just makes stuff disappear and makes it a really easy problem. So color your 0, 0. If it works, good. Shade the rest of the stuff above the line. If it doesn't work, then you would shade the stuff below it. Gabe?
What happens if your line goes through the 0, 0?
Oh, that's a good question. You got to pick a different point. So then I would pick 1, 1. Sorry. Yeah, if it's horizontal or vertical, unless it goes through the 0, 0, you should be fine. Okay? All right, so what do we do if we want to go backwards? What do we do if I tell you, okay, here's my graph. What's the equation? Okay, so it's this, here's this dotted line is my equation. All right, now, I know that I usually write them in y equals mx plus b format. So let's start there. What's the y-intercept? 2, right? Here's my y-intercept at 2. Then what else do I need? Figure out the slope. So I got to pick a point that's at an intersection, so I can pick this one. And then how far down do I go? So what's my slope? Negative 1 over 3. So my slope goes in for which one? And then what's my b?
2.
Plus 2 equals y. So that's the equation. Only this isn't just an equation, it's an inequality. So all we have to change is the sign right here. So is this, what do you think? Less than or greater than? Less than? Why do you think less than? Because it looks like it's underneath it. So we'll try that. We'll put y is less than negative 1/3 x plus 2. Okay, now, is it going to be less than or equal to or just less than? Just less than. How come it's not or equal to? What kind of line is it? It's a dotted line. So I don't put the line underneath it because it's a dotted line. How can I check? Because I'm done. How can I check to make sure I did the right? Plug what point in? Okay, in this case, should it work? Should 0, 0 work? Yes, because it's colored in there. So let's plug in 0 less than, what's 1/3 times 0? Plus 2. And again, that's why I picked 0, because if there's an ugly fraction here, what does it do? It goes away. All right, 0 less than 2. Is that true? Yes. So is this right? Yes. Good, you're done.
Oh, I forgot to write it.
Okay, that's it. All right, it'll be posted. Okay, so that's it. So you test yourself by plugging in the point 0, 0, and then you're done. So let's try this one. So I want you guys to try this one at your seats.
Wait, why did we stop at 3?
What? For the slope? Because that's where the point was? So Gabe, for this one, for instance, I would pick, like, this is my intercept, and then I would pick, like, this one, because that's where there's another intersection point. Whereas if I picked, like, right here, that's not a point, because it's not like a, yeah. How'd you get 2 over 1? That's not at a whole point. So use the points I put on there to find your slope. The rest of it's fine.
I would do like.
Is that the y-intercept at +2? Where's the y-intercept?
See where it crosses there.
-2?
You can't see on the board?
Oh, I'll show you.
-2?
Yeah, so it should be -2. Good. And then what's your slope? So if you go from that point to that point, you're going up
Up like 5
5 over.
over 1.
Good. So your slope would be good. Don't forget your x.
Oh.
All right, and then perfect. And then you've just got to figure out if it's less than or greater than.
Yeah.
Good. So then make it a greater than symbol. Should be 5 over 5 or 5 over 1? Because you went up 5, right? But you only went over 1. Yep, so 5 over 1. The rest of it is right. So then you just need to decide if it's greater than or less than.
Is -3 right?
For the y-intercept, -2.
So decide if it's less or greater than.
Just pick one and then plug the point in. And if it works, go with it. If it doesn't, switch to the other one. Does that make sense? So plug in 0, 0. If it works, then you're right. If it doesn't, then go with the other one.
Wait, what? That's not right.
So then if that doesn't work, then switch to a greater than sign. Like don't put less than, then it's greater than. You have less than. So if it doesn't work, switch to greater than. Does that make sense? Yeah, so if you ever find yourself like testing and it doesn't work, that's what you do.
Oh, it isn't right.
It should be 5 over 1, but yes, the rest of it's right. Greater than? And why is it 1 over 5? Remember, slope is rise over run, so 5 over 1. You go up 5 over 1. And flip your sign. Okay, so let's talk about this. So our original equation is y equals mx plus b. What's our y-intercept?
-2.
Okay, so that's going to be -2. What's our slope in this case? 5 over 1 x. Don't forget your x. A lot of people are forgetting the x there. All right, so that would be the equation of the line. However, I need to decide if it's greater than or less than. So what do you guys think here?
I think it's greater.
Some people said greater, some people said less. So let's do greater than. Is it going to be equals to or just greater than? Equal to, because it's a solid line? Good. Okay, so then our equation is still 5x minus 2. Why didn't I write the over 1? You don't need it. You can assume that it's there, so you don't need it. Good. All right, so now how do I check to make sure that's right? Okay, 0, 0. Should that work or should that not work? It should work. Okay, so 0 greater than or equal to 5 times 0 minus 2. What's 5 times 0? 0 minus 2? Is 0 greater than -2? Yes, that works. So is this sign right? Yes. If it were wrong, then you would change this sign. All right? If it were wrong, flip to a greater than. Okay? All right, so for your exit ticket, you guys have templates for once. Sorry, I was finally on it. All right. So I want you to do 1A, 1B, 2C, and 4A. So all the ones that are circled for your exit tickets.